National Electrical Code, or NEC, does not specifically address the use of crimp sleeves in plastic boxes when different size wires are present. However, industry best practices and manufacturer recommendations generally advise against using crimp sleeves for grounding conductors when dealing with different wire sizes. When connecting multiple grounding conductors, also known as equipment grounding conductors, or EGs, of different sizes in a plastic box, it is recommended firstly, use separate wire nuts for each group of conductors of the same size. For example, use one wire nut for the number 14 EGC and another wire nut for the number 12 EGC. Secondly, ensure the wire nuts are properly sized for the number of conductors. The wire nut should have enough room to accommodate all the conductors comfortably without overcrowding. Thirdly, leave sufficient tail length on each conductor to reach the device terminals comfortably. Typically, a tail length of 4 to 6 inches is sufficient. Fourthly, secure the wire nuts firmly. Use a screwdriver or pliers to tighten the wire nuts until they are securely fastened. The rationale behind this recommendation is that crimp sleeves are designed to connect wires of the same size. Using a crimp sleeve on different size wires can lead to unequal contact pressure, which may result in a loose connection and potential safety hazard. Separate wire nuts allow for easier future troubleshooting and maintenance. If one conductor needs to be replaced or disconnected, it can be done without affecting the other conductors. Using wire nuts of the proper size ensures a secure and reliable connection. Undersized wire nuts may not provide adequate mechanical strength, while oversized wire nuts may not make good electrical contact. While there is no specific NEC code that prohibits the use of crimp sleeves for different size grounding conductors, it is generally not recommended based on the rationale outlined above. Many electrical manufacturers recommend using separate wire nuts for grounding conductors of different sizes. They provide wire nuts specifically designed for this purpose. For safety, reliability, and ease of maintenance, it is best practice to avoid using crimp sleeves for connecting grounding conductors of different sizes. Instead, use separate wire nuts of the proper size for each group of conductors, as recommended by industry best practice and electrical manufacturers. This ensures that each conductor is securely and reliably connected, minimizing the risk of loose connections and potential safety hazard. When selecting wire nuts, always refer to the manufacturer's specifications to ensure they are appropriately sized for the number and gauge of conductors being connected. Using the correct size wire nut is crucial for maintaining a safe and reliable electrical connection. Overstuffing a wire nut can lead to loose connections, while using an oversized wire nut may not provide adequate contact. Furthermore, it is important to properly prepare the conductors before inserting them into the wire nut. Strip the insulation to the appropriate length as indicated on the wire nut packaging or manufacturer's instructions. Ensure that the conductors are clean and free from any corrosion or debris. When twisting the conductors together inside the wire nut, apply sufficient pressure to create a tight and secure connection. Use a twisting motion to ensure that all the conductors are properly intertwined. After tightening the wire nut, give a gentle tug on each conductor to verify that it is securely held in place. If any conductor comes loose, repeat the process to ensure a proper connection. In addition to using separate wire nuts for different size grounding conductors, it is also important to maintain proper grounding throughout the electrical system. This includes ensuring that all metal boxes, enclosures, and equipment are properly grounded to the main grounding electrode system. A properly grounded electrical system provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock hazards. When working with electrical systems, always follow safe work practices and wear appropriate personal protective equipment, such as insulated gloves and safety glasses. De-energize the circuit before working on any electrical components, and always verify that the circuit is de-energized using a reliable voltage tester. If you are not comfortable working with electrical systems, it is best to consult a qualified electrician to perform the work. Electrical work can be dangerous, and it is important to take all necessary precautions to ensure your safety. In summary, when connecting grounding conductors of different sizes in plastic electrical boxes, avoid using crimp sleeves and instead use separate wire nuts of the proper size for each group of conductors. This will help to ensure a safe, reliable, and easily maintainable electrical connection. Always follow manufacturer recommendations and industry best practices when working with electrical systems. Remember to maintain proper grounding throughout the electrical system and to follow safe work practices at all times. By adhering to these guidelines, you can minimize the risk of electrical hazards and ensure the safe and reliable operation of your electrical system. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including grounding and bonding requirements. It is essential to familiarize yourself with the applicable NEC requirements for your specific electrical project. The NEC is updated every 3 years, so it is important to ensure that you are using the latest edition. In addition to the NEC, local electrical codes and regulations may also apply. Check with your local authorities to determine the specific requirements for your area. When selecting electrical components, such as wire nuts, always choose products that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or UL. UL listing indicates that the product has been tested and meets established safety standards. Properly installed and maintained electrical systems are essential for the safety and well-being of occupants. By following industry best practices, manufacturer recommendations, and applicable codes and regulations, you can help to ensure that your electrical system is safe, reliable, and compliant. When dealing with electrical wiring, it is crucial to understand the different types of conductors and their proper applications. Grounding conductors, also known as equipment grounding conductors, or EGCs, are used to provide a lower impedance path for fault current to flow back to the source. This helps to trip the circuit breaker or fuse and prevent electrical shock hazards. Grounded conductors, also known as neutral conductors, are used to carry the return current from electrical devices back to the source. Grounded conductors are typically identified by a white or gray insulation. Ungrounded conductors, also known as hot conductors, are used to supply power to electrical devices. Ungrounded conductors are typically identified by a black, red, or blue insulation. When connecting conductors, it is important to use the proper wiring methods and connectors. Wire connectors, such as wire nuts, are used to join 2 or more conductors together. Wire connectors must be properly sized for the number and gauge of conductors being connected. When installing wiring in electrical boxes, it is important to ensure that the box is properly sized for the number of conductors and devices being installed. The NEC specifies the minimum box fill requirements for different types of electrical boxes. Electrical boxes must be securely mounted and supported. When running wiring through walls, floors, or ceilings, it is important to protect the wiring from physical damage. This can be done by using conduit, cable trays, or other protective measures. When installing electrical equipment, such as switches, receptacles, and lighting fixtures, it is important to follow the manufacturer's instructions. Electrical equipment must be properly grounded and bonded. When working with electrical systems, it is essential to maintain a clean and organized work area. This will help to prevent accidents and ensure that the work is done properly. Always keep electrical tools and equipment in good working condition. Damaged or worn tools can be hazardous. Before starting any electrical work, it is important to plan the project carefully. This includes determining the scope of the work, identifying the necessary materials and equipment, and developing a detailed plan of action. When working with electrical systems, it is important to be aware of the potential hazards. Electrical shock, arc flash, and electrocution are all serious risks. Always take the necessary precautions to protect yourself from these hazards. If you are not comfortable working with electrical systems, it is best to consult a qualified electrician to perform the work. Electrical work can be dangerous, and it is important to take all necessary precautions to ensure your safety. Remember, safety is always the top priority when working with electrical systems. By following safe work practices and adhering to applicable codes and regulations, you can help to prevent accidents and ensure the safe and reliable operation of your electrical system. Always double-check your work to ensure that all connections are secure and that all components are properly installed. A thorough inspection can help to identify any potential problems before they become major issues. When troubleshooting electrical problems, it is important to follow a systematic approach. Start by identifying the symptoms of the problem and then use a process of elimination to narrow down the possible causes. Use appropriate testing equipment, such as a multimeter, to measure voltage, current, and resistance. Be careful when working with live circuits, and always take the necessary precautions to protect yourself from electrical shock. If you are not comfortable troubleshooting electrical problems, it is best to consult a qualified electrician to perform the work. Electrical troubleshooting can be complex and dangerous, and it is important to have the necessary skills and knowledge to do the job safely and effectively. Staying up to date on the latest electrical codes, standards, and technologies is essential for electrical professionals. Attend continuing education courses and seminars to expand your knowledge and skills. Read industry publications and online resources to stay informed about the latest developments in the electrical field. By continuously learning and improving your skills, you can provide your customers with the best possible service and ensure the safety and reliability of their electrical systems. Electrical work is a rewarding and challenging profession. It requires a combination of technical knowledge, practical skills, and problem-solving abilities. By dedicating yourself to learning and mastering the craft, you can build a successful and fulfilling career in the electrical field. Always remember to prioritize safety in all aspects of your electrical work. Electrical hazards can be deadly, and it is important to take all necessary precautions to protect yourself and others. By following safe work practices and adhering to applicable codes and regulations, you can help to prevent accidents and ensure the safe and reliable operation of electrical systems.